Okay, I'm very quickly going to go over a very simple problem of EMF and internal resistance, just to remind students of the principles you would use, and then in my worked examples I'll do more complex problems. Now, this here is a very straightforward circuit. We've got a 6 volt EMF, a 0.5 ohm internal resistor, and we've got a 6 and 9 ohm resistor in parallel. And what's the current in the circuit? There are other things we could ask, like what's the potential difference across the 0.5 ohm resistor? So the first thing we would do is we need to break down the circuit and have a look at different things. The first thing is we need to decide on what the total resistance of those two in parallel is. So we could say 1 over RT is 1 over 6 plus 1 over 9. Now, if we were going to add a 6 and a 9th, we'd need a common denominator, which in this case is 18. So 6 goes into 18 3 times, which is 3 over 18 plus 2 over 18, which is 5 over 18. So the RT over 1 is 18 over 5. 18 over 5 is 3.6. Okay, so we know then, if we were to write this as one resistor, then the resistance would be 3.6 ohms. Okay? So the equivalent single resistor, instead of these two in parallel, would be 3.6 ohms. So if you wanted to work out the current there, it would simply be, what's the total resistance of our circuit? And where students get confused is because this internal resistor is inside the battery. If I was to draw the resistor there, outside of the battery, then students would no longer be confused, because it's just simply adding another resistor in series. So the total resistance in this case is just 3.6 plus 0.5, which is 4.1 ohms. So the current, I, is V over R, which is 6 over 4.1. Which would be 1.46 amps. So the current in that circuit is 1.46 amps, because the total resistance is 4.1, because we can make an equivalent resistor here, and as long as we add it to this in series. If we wanted to work out the voltage, small v, what's the voltage across the internal resistor, and then we could work out the power loss. So the voltage across the internal resistor is V is IR. V is IR, so we know I is 1.46. We know it's the same everywhere in the circuit except where it splits here. So we can simply say for the voltage across this, V equals IR, which is 1.46 times 0.5 which equals 0.73 volts. So the potential difference across there is 0.73 volts. What's the power lost across the internal resistance of the circuit? P is VI, is simply 0.73, which is the voltage, times the current, which is 1.46, will give us the power lost inside this cell here. There are other problems they could ask us. They could ask us to work out the current. A harder question would be to work out the current in, say, this branch here, in the 9 ohm branch. Again though, it's not that bad. If we think about it, we've got a 3.6 ohm resistor, so in order to work out the potential difference across these branches, we could use V as IR again. So therefore I is V over R, where V is V is IR, I'll work it out. The potential difference across this branch here, V equals IR, the current is 1.46, and the resistance is 3.6. That will give us the potential difference across these branches. I could have also used the potential divider equation, which we've spoken about earlier. 1.46 times 3.6 equals 5.26. 5.26 volts. Is it realistic? Yes, it is realistic because it's not as big as that, but it's getting there because this is obviously the bigger of the two resistances. So using V as IR, we're able to work out the potential difference there. If we want to work out the current across the 9 ohm resistor, we could then say, okay, I equals V over R. We know the potential difference across the 9 ohm resistor is the same as the 6 ohm because they're in parallel, and the voltage is 5.26 divided by the resistance, which is 9. So our current in this branch, for example, would be V over R, which is 5.26 divided by 9, which is 0.58 amps. Again, like always, is it realistic? Well, yes, because we know the total current is 1.46, 0.58 of which is going this way. Is it half? Is it more than half? Is it less than half? Well, it's less than half. Why is it less than half? Well, because the majority of the current would favour the 6 ohm resistance because it's got a smaller resistance, so you'd have a greater current going that way. Okay? And that would summarise more or less everything they could ask you about a circuit like that.